So the main topic of chapter 13 is going to be mirrors, and so I have a selection of mirrors right here. And we're going to start talking about, the first ones we're going to talk about is this one right here. That's a flat mirror. This one right here, that's also a flat mirror. These up here, these are concave mirrors. And then these two right here, these are convex mirrors. Okay, so I'll just sort of go through them one by one. Flat, we're going to talk about that in a second. And then I'm looking at this one right here, and you can sort of see a magnified view of the lens there. This one has less curvature, so this one has less curvature than this one. And so you'll notice here it's right side up, this one is upside down, this one's magnified, and then you kind of look, this one has more curvature than that one, and you'll see also, let's see, this one's right side up and that one's right side up. So we'll look at these here sort of one at a time. And so right off the bat, what we're going to do is we're going to look at our flat mirror. So we've got a flat mirror, and I'm going to have to sort of figure out a way to set up the camera so that you can see a little bit better. But basically the law of reflection is pretty simple. It says angle of incidence equals angle of reflection. So basically if I have a mirror that's a little bit like this, and I have a ray of light that comes in like so, it's going to bounce out like so. So I'm going to have a ray of light that comes in, strikes my flat mirror, and then it's going to bounce out at the exact same angle that it bounced in at. So this is my flat mirror. And this is my incoming light, this is my outgoing light. And now here's what we have to do, is we have to define a perpendicular to the surface. And while I'm drawing that, I want you to think about what vocabulary word do we use for perpendicular to a surface. That's right, it is normal. This is our normal. So here, as measured off a normal, it comes in at 40 degrees. So that's 40 degrees theta I. And so then my theta R theta reflected is going to be 40 degrees the way that I measured it. Okay, so angle of incidence equals angle of reflection. Okay, so then what we can do with that is we can think about our good, one of our nice little problems is I have a person here I've got a person and there's a mirror on the wall. Now, the question is, how long does the mirror have to be in order for the person to see themselves in the entire mirror? Well, if this person, our little person here, if they are basically exactly 10 centimeters tall, then I'm going to choose, and their eyes are about 9.5 centimeters off the ground. Let me flip it around like that. So their eyes are about 9.4 centimeters off the ground. Well, by my angle of incidence equals angle of reflection, 9.4 divided by 2 is going to be a little bit less than 5. 9.4 divided by 2 is going to be 4.7. So they're going to look, if they want to see their feet, they're going to look to like this point here. And so they're going to look like this. And then that's going to come off at the exact same angle. And they're going to see their feet down here. And then just very small little adjustment up here. Their eyes are going to look to see the top of their head. They're going to look right around there. And so to see the top of their head, they're going to look at a point just a little bit above their eyes. And that's going to make a very, very small angle. And so the mirror only has to be that long. The mirror actually only has to be half as high as the person is. If the mirror is half as long as the person is, they will be able to see their entire body inside that mirror. And this is something that kids have a lot, well, people in general have a lot of trouble with. And then they say, well, what happens as you get closer? Well, as you get closer, these angles change, but the overall geometry does not change. So whether you're far away or whether you're really close makes no difference whatsoever. That if we kind of look here, that's how much of the camera I can see. Now what I'm going to do is I'm going to push it up, right? And the camera gets bigger, yes, but the total amount, if you look at like the total space around the mirror, the total space around the mirror doesn't change. And so if I think, you know, you'll just have to think about that. So like here's the mirror, here's the camera. Well, it's kind of hard for me to see. But if you look, the relative spacing, sure, the camera gets bigger or smaller, but the relative spacing in the mirror stays the same. Okay, that's that video.